This video is gonna show you how to how to measure slopes. Uh, Typically, you're gonna set up a builder's level. You'll put a Philadelphia rod here and a Philadelphia rod here, so you can measure the difference, right? For example, so ultimately, we're looking for this angle right here. Right, and we're going to be looking for it in slope, not degrees, maybe. All right, so you're going to have a Philadelphia rod measurement there and there. You're going to subtract them, and that's going to give you the 8.44. So this minus this will give you this. Those kind of go away. They'll be in your book, but they go away. And now you have the rise and the diagonal. To get the slope, you need the rise divided by the horizontal. But rise divided by the run, not the rise divided by the diagonal. So if you do that, right, the rise divided by the diagonal, you'll get 12.92%. That is not a correct answer. Not far off. For most dirt work, it's going to be fine. But to get an accurate slope, you're going to want to take the rise, which is 8.44 divided by the horizontal. So to get the horizontal, you're going to go square root, open parenthesis, 65.30 squared minus 8.44 squared, close parenthesis. That will give us, I did something wrong, square root, open 65.30 squared minus 8.44 squared, close parenthesis. Copy that. And then Control V equals all right, that'll give you this horizontal here. Now you can do the slope. So 8.44 divided by Control C, compute, Control V equals Control C. All right, that's how you get that slope. The proper slope is 13.03. That is a good one. This is not. It's not a huge difference though. It's looking like 1303, almost a tenth of a degree, which isn't, for dirt work, that's going to be close enough. So let's look at this then. All right, so that's one way. Here's another way. I was just explaining so I'll do that again, trim that out. All right. So this is kind of an arbitrary location, so we don't know the distance between this, right? We just have a line right here that we know is at 225 feet. And we're going to plumb down here, right? Because this is where we want to know from this point to this point, what's the slope? So to do that, we're going to do this. We're looking for this triangle here, right? So we know the diagonal. That's something that we can field measure. We have this line here that's 225 feet. We're going to plumb up H, V. So when you make your measurement, you want it to be plumb, right? We come up with 18.56 and 3.48. So to do the subtraction again, 18.56 minus 3.48, and you'll get it's 8.44, no, 15.08. So that's the number we're looking for. Get rid of this, get rid of that. Those are in your book. And that line's not really relevant anymore. So we're going to do the same tools, calculator, 66.48 squared minus 15.08 squared. We want the square root of all of that. Copy that. Compute. Control V equals. Copy. Control V. All right. So now we have what we need. We have the horizontal, right? We can measure that. I can show you that. 64.75. Now we can do the 15.08 divided by the run. Then we'll actually get the right percent. $23.29, right? And to check that, I want to show you why that is 23.29%. So if we click on this horizontal line and we make it 100 feet and we trim this, this will be 23.3, right? 23.29, 23.29. I don't know why it's rounded up. One rounded up, maybe the. Anyways, that's what we're looking for. 23.29, 23.28. I don't know, 10 thousandths off in the decimal, so something was rounded. Yeah, that's how you. That's why it works, because this is 100. Right? 23.28 per 100. 28.20. 28.28. 23.28 per 100, which is 23.28%. Last technique here would be Abney level or theodolite or total station, some other angle inclinometer. Yeah, so I'm not sure what that is. Inclinator, I think it's called, but you can call them inclinometers too. So this, the technique here is that this is at the same height as your eyepiece, or the eyepiece or whatever part of the instrument you're working on, your eyeball, if you're working with an Abney level. I looked that up a second ago. Abney level, and the reason why I looked up Abney level, that's an Abney level there. So you can see the horizontal line, the bubble, horizontal bubble, and tip it down until you're on the eyesight. It splits the image. So one's looking at the eyepiece, the other looking at the horizontal bubble, and they give you the inclined angle. Now here, if you look on some of the old ones, they'll have grade in feet per surveyor's chain. Can you see that? Grade in feet per surveyor's chain and chain correction. Interesting, is I saw an old style one, I didn't recognize it, so I looked it up. Thought I'd share that. And we want to go back to this. There you go. That's pretty much it. You just make sure that this ribbon or target that's on the rod is the same height as the eyepiece on the instrument or your eye if you're looking through an Abney level. And then it's a direct read for the inclined angle here. Here it's 13.7. So if you want percent, you got to take the percent and you got to convert it. So you're going to go 13 degrees. So right off the bat, we got 13. And then you subtract 13.71. Right? We subtract the 13. And then you multiply 71 times 60. 71, no, it's 0.71, so it's multiple, times 60. Compute is 42. Delete. So T 42 minutes. No, what am I looking for? We're looking for slope. 13. No, so sorry. Went the wrong direction. Tangent, TAN, much simpler. 13.71. Close parenthesis. That'll give us a 24.4%. Let's see if we did that. H, point relative, negative 100. H, trim. .39, 24.4, right? So that's how you get that slope. Not sure if I made that clear. To convert the 13.71 degrees, you get the tangent of that. We came out with 0.244, which is the same as this. If we do it around it one more time, right? 24.4%. So it matches up, and that's when we made that 100. That's why. Oh, that's odd. Thought I made that 100. Length is 100, right? Oh yeah, no, the wrong thing. 124. That's it. So 24.4 or 24 per 100. So that's a decimal place. You're just moving the decimal place to make it per 100 per cent. Cent means 100. Hope that helps you in your career and helps you understand how to lay out slopes. And please share, and thanks for watching.